What's up everybody, welcome to another Python 3 recipe, and today's video title is when not to use a list. Yes, lists are great, they're beautiful, they're mutable, they're flexible, they're everything you like, but sometimes you're really not doing yourself any favor not considering something else, alternative options, because believe me, there are use cases where you are clearly better off choosing alternative data structures to store your sequences. And to see that, we have two problems in this recipe, and the first one, let's consider the first one. So let's say we are continuing on our movies reviews website, and at each point in time we just want to keep track of the 10 latest reviews that are added to a given movie, with the oldest one at the beginning of the list, at the beginning, and the newest ones at the end. And we want to make this in a very efficient way. So this is the purpose of this. This is the problem statement basically. We want to keep track in a FIFO way, first in, first out, the reviews, and just keep track of the 10 latest reviews added to a given movie. How do we do this in an efficient way? What are the alternatives to lists that allow us to do that efficiently? Well, the answer is we can use DQ. So let's say we have this list of 10 reviews that are the current 10, the latest, the 10 latest reviews added to a given movie, and we have a new review added by a user, and we want to store it in this list. So let's first consider the case where we are still using a list, and just to see why it's a bad idea to use a list for such case, because obviously we can do that with a list, but it's not very efficient. Well, the way we can accomplish this with a list, let's run this first code snippet. Oh, let's see what's happening. Let's first run this, I think, and then this one, and then this one. All right, so with a list, like we said, for each new review that we want to add, we first want to make some space. So in order to make some space at the left, we have to pop the value that's currently at the left, which is this 2.5. So we have to pop this value, and the problem is doing that is complexity. The complexity is big O of n, and the reason is when you pop here, you're creating an empty space, which means that everything to the on its right has to now be shifted to the left by 1, which is big O of n, which is not very time efficient. Imagine doing this in a list that is 10,000 million records or a billion, which is not very efficient. So just to sum up the example using a list, now that we have made a space, because we now have 9 instead of 10, we have to append the new review at the end. So that's what we do, and now the review that we wanted to add is at the end, 2.5. Now that's it here, we have added it, and that's it. But there's a better way. There's a better way, because this operation is costly and you don't want to do that all the time, especially if it's something that you're doing frequently. And the better way is to use a DQ. And to see that, let's run this first code snippet. Alright, so here we are trying to construct a DQ with the last 10 reviews. Instead of a list, we are using a DQ, and we have to make some space at the left to store the latest review. So if we pop this using this instruction, the advantage of popping it this way is that this way of using a DQ, this operation is constant time. So the time complexity is constant. And the reason is that under the hood, DQs are doubly linked list, and they use linked list to store the information. So here at each point in time, the way to identify what is on the left is just a reference to this value, and actually removing this is just a matter of moving that pointer to this one now, which is just a constant time operation. So it's like moving a pointer that was pointing to this value to this. So this now 1.1 becomes the left of the DQ. So it's a constant time operation. It's not costly as popping something from the beginning of a list. Now that we have made some space, we have now the freedom to add something new, to add the latest review to the end of the DQ, which brings us back to a DQ of 10 reviews, which is what we want. We want to maintain at any point in time the list of the 10 latest reviews added to a movie. But there's even a better way using DQ, because remember, so far we have been doing those operations in two steps, popping and then appending. But DQ, provided that we have given the max length variable, can enable us to do these two steps in one go, in just one instruction. So here we initialize the DQ with the parameter max length equal to 10 to instruct the DQ that every time that we append to the right, we want to pop on the left by 1. So that's what this instruction is, that's what this means. So every time that we are appending, if the DQ length is already equal to 10, then we need first to make some space before appending the new value. So let's run this code snippet to see what it returns. It does exactly the job that we did here in 2 steps, but just in 1 step. Okay, so now just to make the idea sink more in our minds, I created these two kind of toy examples. So here I'm building a long list, which is basically a list of 10 to the power of 7 and a long DQ. And my goal here is to compare the time it takes both to insert at the beginning of a list, of the long list, or insert at the beginning of a long queue, and compare the time it takes for both. So here, let's run this, and let's run this. Okay, so you see, inserting at position 0, the value 4, at the beginning of a long list is, given all these metrics, is almost in a matter of milliseconds. So here you have 21.5 milliseconds, whereas here it's just 7.8 microseconds. So the performance is enormous. The performance gain is enormous. And here, similarly, if we consider the case of popping, which was what we were doing in the previous example, it's pretty much the same. So here, if we do this and this, you can see that indeed we are having a massive performance increase by using a DQ over a list. So this sums up the first scenario where you definitely want to consider something else to list when you have to store your data. Just to sum up, if your use case requires you to constantly pop or insert at the beginning of the sequence, then using a list is probably not what you want to do. You want to use a DQ for that. And the second problem statement, which enables us to show that sometimes lists are not the best option, is the case where we have a huge list of values for which we know in advance their type, and we want to make some performance gain both in terms of memory and time on our code. So in order to do that, the best alternative that we have provided by Python is to use the array class, which like we saw when we did the sequence overview recipe, internally uses the C type to represent the data. Because remember, when we are creating a sequence using array, we have to provide beforehand, unlike list, we have to provide beforehand the type of data that are going to be represented in that array, which translates into massive performance gains, because knowing beforehand the type of a data, the Python now knows how long it takes to represent each element in the sequence in memory, and can do that in a much more compact way, and also using the C-type representation, which is basically telling you that using array, if you can, provides you with almost C-like performance gain on your code without losing all the flexibility that you have with list, because array almost has the same API that list has, in terms of you can append, you can pop, you can insert, you can remove, and it's mutable, so you're not losing much. The only difference is that you have to know in advance what is the type of elements that are going to be stored. And in order to make that idea even clearer, let's run these two examples. The first case is with list and the second case is with array. And basically here we are trying to construct a very long list of floats. By long I mean 10 to the power of 7, and we store that list in a file, in a text file, and then we retrieve all those values back in a separate list from that text file, and then we compare if the two lists contain the same information. And this takes 20 seconds almost to run, doing this operation using list. So I'll run it again, and while it will be running, we'll move to the example with array and see how long it takes. So like we said, with array you have to provide the type before, so that Python knows how to represent it internally. So here we are using doubles, and again it's the length is 10 to the power of 7. So here we now save it in a float, the floats.b, which basically means that it's not relevant, the extension that we put. What is relevant is here, this b here. We are just telling Python that this is saved as binary, and we can save as binary because internally, like I said, this is stored using the C type representation, which is much more faster and takes less memory. So here we save like we did before. We did in this case, instead of saving as a text, we save as binary, and we retrieve it back from the file again, but we store it in a separate variable. And once again we compare the two. We compare the two values, the two lists, the one we use to store and the one we use to read. And how long does it take to run this snippet? You see here it's 2.4, and here it's 20 seconds. So almost 10 time performance gain by using arrays instead of list. So this is another use case, this is another scenario where you have to consider twice before saying if you want to use a list over something else. And that's the end of this recipe. Hopefully you learned something new. If the case, please give it a thumbs up. Also feel free to ask any question in the comment section. I will do my best to answer those. As always, you can find the link to the code in the description below. Be sure to subscribe for future videos, and thanks for watching.